Hello, let's continue our Sudoku adventure with Connection Lost by Matt Tressel. This looks like a really interesting constraint. I don't think I've done it before, but it is familiar in some ways. Cool, let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these purple circles in the grid. These form kind of like imaginary Ren bands, a bunch of them. So for every row, column, and box, the circles that appear in that row, column, box form a Ren band. So let's take this, for example. Maybe this row, for example. These 4 circles in the row have to have a set of non-repeating consecutive digits in the order. They're already not going to be repeating, but they have to be consecutive. So for example, I could place, but any order, so I could do like 2, 3, 4, 5. 2, 3, 4, 5 is a consecutive run of digits. The order doesn't matter, so this fulfills our circles just fine. That's one way to do it. There's plenty of ways, though. But keep in mind that, like, if I do that, let's replace this. This 5 also is telling us that this it's part of this column. It has to be part of this Ren band. It's also part of this box. It would have to be part of this Ren band. So that would actually not be valid. I'd have to do like something like this, maybe. So now this, so even though this Ren band is a full Ren band, this is also a Ren band on its own because it's in this box. This is also a Ren band. So keep in mind the boxes are doing it too. All right, the Nabner squares work very similarly. We're just forming virtual Nabners here. So for example, in this row, these 3 form a 3-cell Nabner, meaning that if a digit appears in one of the squares, then its consecutive digit does not appear in any of the squares. So let's just take a really simple example. If this was a 2, then this cell and this cell, because they form a Nabner in the row and a Nabner in the box, are not 1 or 3. They're also not 2 because of Sudoku, but they're definitely not 1 or 3 also, because that would make them consecutive with the 2. All right, so if a digit appears in the square, then its consecutive ones do not appear in a square that shares a row, column, or box with it. Seems very powerful. All right, cool. Well, that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So the first thing I noticed was this given 1. Renban plus Nabner, there's always, if you only include Renban and Nabner in your puzzle, there's always going to be 2 solutions to the puzzle. Because you can always swap the 1 with the 6, the 2 with the 5, and the 3 with the 4. Because they're both only dealing with consecutiveness, so you don't know which end is which. So this given 1 is there almost certainly to just tell us which order those go in. But it is a 1 that's looking at a 3-cell Nabner. So I do believe that forces it to be 2, 4, 6. What's a good way to think about it? Well, the first thing is it does need a 2. Because if it didn't have a 2, then what's left to place in our Nabner? Well, it would be 3, 4, 5, 6 is what's left. If it didn't have a 2, then 3, 4, 5, 6 is what's left. I cannot pick 3 digits from here, which wouldn't have a consecutive buddy, right? I want to take one of the extremes probably. So I take like a 3. That would remove the 4 as an option, but now the other 2 are 5, 6. That's no good. But if I didn't pick the 3, it's even worse because now I'm 4, 5, 6, right? So I have to have a 2 on here. Once I have a 2 on here, I can't have a 3. And so it's going to be 2, 4, 5, 6. But within the 4, 5, 6, those 2 can't be consecutive. 4, 5 is consecutive. 5, 6 is consecutive. So I can't include the 5. The 5 removes the 4 and the 6. So we end up with 2, 4, 6, which is all even. That's one way to prove it. That leaves 3, 5 pair here. It's tempting to even odd color here, but I think I'm going to hold off on coloring for now. I think it's going to add some complication. I think it's just kind of, it's natural to want to even odd color when you're dealing with consecutive stuff, but I don't know if that's necessary right now. We will later if we need to. So how do we continue from here, I guess is the question. It's interesting. We have this column, which has a 4-cell Renban and then a 2-cell Nabner. So if you think about a 4-cell Renban, there's only 3 options. And when you have long Renbans, like Renbans that are longer than half the length of, like half the numbers, it's sometimes easier to think about what numbers are excluded from the Renban. And so you can only shave off the ends. It's missing 2 digits. So it's either missing 1, 2, 1, 6, or 5, 6. Now, if you think about it, the 2 missing digits are going to end up in the Nabner, and they're not allowed to be consecutive. So we can't be missing 1, 2, or 5, 6. So we have to be missing the 1, 6. And that leaves 2, 3, 4, 5 for this guy. Maybe I should pencil that. I don't know. Is that worth penciling? It's going to be pretty busy. Let's not pencil that yet. I'm just going to go through every column, every row, every box to see if there's anything else interesting to do with those. Because I feel like I just scanned this row and it's got the same thing. So we can do the same exact logic. This is a 1, 6 pair. Oh, this box also, that will be a 1, 6 pair. Okay, so we're getting some 1, 6 pairs here. This 1, 6 pair looks up, telling us this isn't 6, but it also has a 1 in it. And so this can't be a 2, because we know there's a 1 down here. So this is our 4, because remember, this is an Abner. So these can't be 4. 4 does not affect this 1, 6 at all. Okay. Any other follow-ups here? All right, again, let's keep looking at, I guess I'm starting with columns here. These are consecutive. I don't think I can do anything with that. 2, 6 against this guy. I don't think I can do anything with that. 1, 6 versus 2, 6. Is that interesting? Not quite. I don't think so. We also have this Renban. I don't know. That's hard to think about. I'll come back to it I'll come back to it. Let's look at rows. This row does nothing. Oh, this row also has the 1, 6. See, it's really easy to miss these. That's why I'm going through each one. This has 1, 6. So these are also 2, 3, 4, 5. I still don't really want to mark that. What about this? What about this though? These have to be consecutive. So they can't have a 5 on them, right? 5 can't be with it, has to be with the 6 or the 4, but the 6 and 4 are gone. That means this has to be the 5. And that leaves this as the 2, 3 pair, the only consecutive that was left. All right. That means this can't be a 5. These two are consecutive, and 2, 3 is not going to be consecutive with the 5. So that's a 3, and that makes that 2. That's our 5. 3 in the corner. That's nice. That's our 3. Now remember, these two are consecutive, even though this is also a Renban. For the box, this is a Renban. So this has to be 2 or 4. Oh, wait, for the box, it's just 2, 4 left. Okay. So I didn't have to do that logic, but whatever. I feel like we're a little bit limited over here. So let's just write out 2, 4, 5. That's what's left for the row. But we know it has a 5 in it. So it can't have the 2 in it because 5 and 2, what would this be to bridge the 5 and the 2? It'd have to be both a 3 and a 4, right? It just doesn't work. This is one Renban. So this definitely has the 4 in it, which makes this a 2. So this is 4, 5. So that's our 4. This is flowing pretty nicely. So this is either 3 or 6. I don't know which one for this Renban. This is also a Renban. Okay, I guess one important thing is it doesn't have a 1 on it because this is 4 or 5. 1 would require 1, 2, 3. So this one sees these two, and this doesn't have a 1 on it. So that's our 1. That's 6. That's 1. That had to resolve in some way. I'm trying to see what to follow up with here. So there's a 1 and one of these two for what it's worth. 4, 5 pair. So 1, 2, 3, 6. 2, 3, 6. Okay, I've lost the train of thought here. What's our follow-up? Okay, we have 2, 3 here. So this is 4, 5. This is 2, 3. Let's make sure we mark that. This is a 1, 6 just for the column. Yeah, this is 1, 2, 6. This is 3, 4, 5. Let's write that out. Ooh, does that interfere with our Renban? Yeah, this can't be... This can't be 3, 4, 5. That's the point, but... Oh, okay. Oh, never mind. I was going to ask where the 2 is, but it could be up here. Oh, sorry. This 1 removes the 2. Really easy to miss stuff like that. This one removes the 2 from here. So that's 6 and that's 2. That makes that a 3. Okay, that's progress. 4, 5 pairs. So this has to be... Yeah, the 2 in the column goes there. That's 3 and 2. Okay. Now 2 in this box goes here. 2s are done. This is 1, 6. What's going to resolve these 1, 6s? Oh, the 2 does. Okay, so that's because of this Nabner. So that's 6, that's 1. Really easy to miss them. That's 6, that's 1, that's 6, that's 1. I should probably have been following up a little better on placements. We placed a 2 here. There's no 1 on these, so this has to be 3, 4. That makes this the 5 and the 4. Okay, I think we're wrapping up, I hope. 1, 2, 3, 4. This is 5, 6. This 6 says that's 5, that's 6. So that's not a 5. Do we have... Okay, these two are consecutive. So they have a 4 on them. Because you can't do 3, 5, right? So it has to have a 4. So that's not a 4. What else? Oh, this is consecutive. So this can't be a 5. This is 4 or 5. 5 has to be consecutive with this. That's 4. So that's 3. We get 4, 5, and 3, and we're done. Neat puzzle, Matt. That's intricate for sure. Really hard to kind of track everything. A lot of this puzzle is following up really well on on deductions, which I feel like I did an okay job. There were a few that I missed for a little bit, like this one eliminating the 2 from there. I missed that for a while, but cool. Yeah, there were some neat initial deductions too. All this row, this column, this row, this box, forcing the 1, 6 into the Nabner. That's pretty neat. And then this one, this is classic Nabner. This 1 forced this to be 2, 4, 6. Cool. Anyway, by the way, Nabner is Renban backwards, if you didn't notice. Invented by Zeta Math. Anyway, if you enjoyed this, why not leave a like, subscribe, and a kind comment below.